afternoon, everyone. Welcome back. Nice to see you all. Just to make sure you're in the right place, this is the Introduction to Project Management 22491, and it's for mechanical and aerospace students. Can anyone hear me okay at the back? So while we're kind of waiting for things to settle down, maybe introduce myself. My name's, I suppose my title is Dr. Paul Bagley. I am a lecturer in project cost management, and I've spent a career in project management related work, mainly applied research, but also in industry. I did my first degree here many years ago, 1993, in mathematics, but over the campus in UMIST, the old University of Manchester Institute of Science and Technology. And I went on to do a master's in manufacturing, and then went on to be a research assistant, paid £11,000 a year. Never got over that. But in a project about cost model development for Airbus and Rolls-Royce, and a requirement to use artificial intelligence to develop new cost models for composite parts. At the time, late 90s, composites were a new thing, and so were the processes and materials. And our job as a research team was to investigate the cost of something of which there was no historical data. There was no precedence for composites at that time, and indeed they were used to decrease the weight of aircraft, but surprisingly some parts are heavier than their metal counterparts once they've been designed and manufactured. I went on to Durham University, where I worked with small companies in the northeast as part of a regional development funding from our partners in the European Union, but also looking at Dassault System digital tools and how they can be used to improve manufacturing. And our main focus was lean continuous improvement projects and the new agility of the time. We could talk a little bit about that during this lecture. I then moved to a place called Cranfield University for 12 years. That's an old RAF base in Milton Keynes, and that's mainly aerospace, mechanical engineering, a very famous school of engineering there. And I worked with some of the Siemens NX products, computer-aided design, finite element analysis, digital simulation, factories, and lots of applied research projects on project management, mainly cost, trying to estimate and manage cost for companies like BAE Systems, Ministry of Defence, Northrop Grumman, also construction, Cadent Gas, the old National Grid, in fact I counted 26 organisations over 12 years. Then I did a project for National Grid when I was at Cranfield on estimating social cost. So nowadays people are interested in society and the impact on society of projects. This will be common for you in your careers, I guess, as life goes on. And I worked there for 12 months on what was called the Rio 2 project, which was planning for the next 5 years for the gas distribution replacement plan. So basically digging up the road and changing the pipes, changing valves, pressure reduction stations, all sorts of esoteric engineering. Then I moved to the University of Bedfordshire, where I taught project management for 2 years, and I've been come back to Manchester for the last year. I'm kind of, just like everybody else, just getting over the pandemic, so it's good to be back and talking to people. Please feel free to ask questions during this session. I've tried to make it as interactive as possible, because I realise, your background is aerospace, mechanical engineering, and project management is something which has historically been seen as something maybe a little bit different. I don't know. I'll try to explain to you why it really isn't, why it helps you and complements you in your future careers. It could be it could be that extra skill which gets you over the line to get the job you want. In some of the major OEMs, original equipment manufacturers around the world. Project management is becoming really critical for the economy. So that's enough about me. So, coming on to some of the teaching and learning we're going to do here. As I say, I'm going to try and make it active learning, so I'm going to ask you questions and get you to solve bite-sized problems and use this technology called Mentimeter, which allows you to interact with your device. You go to a particular website, type in a number, and you vote on your answer, or you input your answer, and then there's instant feedback on the screen about what those answers were, so we can get form some sort of consensus over the answers which we develop to problems. And I've picked a kind of theme which you don't have to observe, and this is by no means, I'm not going to collect any assignments on unmanned air vehicles, but I've picked a theme, this theme of unmanned air vehicles, as I'm not that expert in UAVs. I've studied some of the cost work on unmanned air vehicles as they've become a new technology to a more accepted technology. But I think it's maybe an interesting aerospace type project we can try and work on just to answer the simple problems. But as I say, you could choose any project you like, even a domestic project or something which is a hobby or something like that. Anything which you consider to be a project, you're welcome to try out the problems on and compare answers. I think a lot of project management includes the context of engineering, and I think as a point of interest, I've put this The Engineer, which is a useful publication, and it's sponsored by some of the main universities, and it just provides you some information, some useful contextual information about projects and what's happening in the world. And you could get asked that at an interview, and it's useful to know what the major projects are and what's happening in terms of latest technology, what the major problems are, the political forces, the technological forces and so on going on in the economy. So we're going to give you that link here for you to look at a bit later on. I have got a few slides here which I've taken from the latest issue of The Engineer just to demonstrate a project for you, which is one of our initial problems or questions to answer. And I've got this resource here which is about, at the end of each lecture, just like you to, when you go home and start to reflect on lectures at the end of the day, it could be any subject really, doesn't have to be mine. But drawing a concept map is a useful thing to do, and it's quite simple. You start to identify concepts, you start to reflect and think, okay, what concepts have I just learnt about? How are they related to each other? Is this a hierarchical knowledge structure I'm thinking about? So this link on concept maps is a useful study tool. It's a useful way of learning and reflecting on things. Sometimes you don't learn something until you reflect. You stop, you think back, you reflect on something, start to ask yourself questions about something, which is more active rather than descriptive. So there are some useful links. Now I've got some, let's see, PowerPoint. I've got some interesting videos here which I hope they work. Let's see if I got to do anything about the volume. I don't know. Let's just see. Oh no.
I've been through this page before. I think you just like browse YouTube and a lot of applications.
Thank you.
Everywhere you look, projects are underway. Whether you're recruiting a new member of staff or constructing the world's tallest building, every project needs a manager to ensure its success. Someone with their eye on every detail, at every stage, from inception to completion. Put simply, project management is about getting things done. It's about knowing exactly what you want to achieve, how you're going to achieve it, and how long it will take. It's about ensuring that everyone involved shares and understands those aims before the first steps are taken, and that they continue to as the end of the project, whatever it is, draws closer. Because successful projects don't just happen. They're not just a long list of jobs to be done. They're a masterpiece of planning, management, organisation and communication, a carefully choreographed sequence of events where progress is smooth and steady. One step leads seamlessly to the next, and every possible hitch has been considered and counted. A successful project needs people with the right skills and knowledge at its heart. Working together, a well-managed, motivated team with clear roles, responsibilities and reporting lines will carry a project to its conclusion without compromising on time, cost or quality. Project management is a wonderful thing, but it's easy to forget how the world might look without it. Because, at its best, project management is virtually invisible. It's the absence of problems and the prevention of failure. But behind every successful project, whether it's changing the way a company works or the organisation of an important event, there's an unsung hero, the project manager, who kept everything and everyone on track to ensure the delivery of the desired result. At APM, we support project managers in all the amazing work they do every day. If you'd like to know more about project management, visit us at apm.org.uk/whatispm.
And I have this link. I worked on this. Let's see. Send. So this is about the Queen Elizabeth aircraft carrier, which I had the pleasure of working on for only 3 months in a research project, which was about, well, the research question was, what are the most relevant best practice and maintenance technologies across industry which will add value to the Queen Elizabeth aircraft carrier support. We call it the support envelope, which is all the systems and organisations which go towards the maintenance of such a tremendously significant project. The project was so vast, over 2 aircraft carriers, there weren't enough welders in the UK who would qualify to the right level. When they looked at the capacity of the country, they had to develop more welding capability. So it's such a vast and significant project.
The HMS Queen Elizabeth is a transformation for the Royal Navy and for the entire British Armed Forces and indeed for the country. She's a strategic asset that's going to be playing on the world stage for the next 50 years. So while she's been in build for the last couple of years, now we've got to understand how we're going to actually use her and operate her. The day is coming very quickly when HMS Queen Elizabeth will be sailing from the further forth into the North Sea for her sea trials. And I think for the thousands of people who've been working on this project, it's going to be a very exciting, I have to say, a very proud day. Very proud day for the nation, proud day for the shipyards around the country that have had built parts of the ship, and an exceptionally proud day for me as the first captain when I take that ship and we put power through the water and we take her out, and wow, what a great journey we've got ahead of us. Well, I have to say, when I drive HMS Queen Elizabeth through past the Round Tower into her home, which will be Portsmouth Naval Base, it's going to be a very special day. I think and I hope that hundreds and thousands of people will come down to watch this magnificent ship, the largest ship the Royal Navy's ever had, come into its home base port. For me, and for the ship's company on board, it's going to be the culmination of probably 10, 12 years of very hard work.
So you see, projects are, some of them characteristically very complex, very difficult to do something predictable. Therefore, you require methods and a common understanding of those methods, which an organisation like the Association of Project Managers are about, but also we as a university are about. We promote project management in our undergraduate community. So in learning these techniques, they're equipping you, preparing you to work on really significant projects like that, so that you can understand the context of project management, why you're doing it, what the problems are, what will go wrong, because most projects go wrong. You just have to look at the news about that, how many headlines there are about over budget and over schedule. You can talk to some people who said, you know, the submarines were over budget and over schedule. If you talk to the engineering community, they say, we gave you what you wanted, you changed your mind, you changed your requirements after we started. So there's a huge engineering change program, which therefore sent the project over budget, over schedule. That makes the headlines, becomes a political talking point, and people get voted in and out sometimes on the strength of projects. Just look at HS2 and the so-called Northern Powerhouse, where the rail project was pared back, was limited. That was a project management decision which perhaps, you know, could cost some political heads. So here's some of the latest from the engineer, and this is a speech by Boris Johnson. You just got to look at some of those numbers there. Rated at 3.2 gigawatts, the proposed twin reactor power station received planning permission in July 2022. If you read a bit further on, it says the company predicts that around 1.5 billion will be spent in Suffolk during construction. Those numbers are very round numbers, by the way. There's one thing which you note about that. If you talk to some of the construction community, these things have not been done before. You know, there's no reactors being built for a long time. No one knows anything in terms of historical costs. So it's very difficult to make an estimate or a claim to a level of certainty if you've got no past experience of what's going to happen, especially considering that the community forgets how to do things. People move on and retire. In the oil and gas industry, they were called the Vikings of the North Sea, the people who originally dug the wells for the oil industry off the coast of Scotland. Lots of them retired, and the industry suffered in terms of its capability. So I guess those numbers are going to be what's called optimistic. They're going to be biased, And it's an accepted thing in project management. There'll be optimism bias where people think it's going to do more and cost less. And indeed, to reflect that, in the so-called Her Majesty's HM Green Book, which is a best practice book from the UK government on how to estimate the cost of projects, there's a table of optimism bias percentage uplift factors. So I would say that these numbers are far from accurate and will probably could be up to 100% or more wrong. They could be really optimistic. Especially when there's a political agenda. These things have got to work. And, companies want to have the business. And perhaps some assumptions have been made which are not particularly accurate or are not really recognising the level of uncertainty in some of these parameters. And here's some more headlines which are not unusual, and all of them can be linked to problems in project management. So things like the National Audit Office slams the MOD for 1.35 billion cost of poor project management. And perhaps that's a number of things there. Poor planning, which we'll be doing in lecture 2 and lecture 3, and use of lessons learned. So a key part of any project is to recognise what went wrong last time. And therefore in businesses you should have some sort of system like SharePoint or some sort of capture of the previous project, which isn't necessarily true because some of these previous projects happened in a non-digital age or where the digital tools were not so advanced. In the project I was on at National Grid, we recorded everything in SharePoint and then that data's captured and stored for the use in the next, say, 5 or 10 years when the next project team come round and they need to look at what we did and where we went wrong, because we did go wrong in lots of places. So there's lots of really common project management problems there, especially, let's say, the NHS IT system. IT is notorious in being the product of subjective judgments of programmers. Programmers trying to make solutions to people who don't really understand the impact of their requirements. I've worked on smaller projects in IT and people want to move the button over here, you want to introduce several new screens, could you just do this? And in fact, these really low value requirements, things you don't really need, could cost days, months of effort. So it's NHS, this IT systems, certainly proprietary ones, which are one-off, so they don't reuse code, are notorious for being very difficult to bring in on budget and on schedule. So there are some really common mistakes here you see in projects. So hopefully you can see now why you should be doing project management, why it's relevant. I don't know what your favourite subject is at the university, but it could be your role in the future, your first role, or your continuing profession, your trajectory. You could, like the computational fluid dynamics, or manufacturing engineering, and all these are roles in projects. So you'll be working with, designers, material scientists, business people, management accountants, test engineers. You have to test what you do. Clearly project managers, procurement, suppliers, procurement specialists, and you'll develop your own trajectory in your career, which you may change. There are jobs which won't exist now and exist in the future, perhaps in artificial intelligence, and different things like that. So you'll work in a team with your colleagues in different areas, and you'll contribute to each other, and you will have a constant dialogue to help you solve the problem. You've got to solve the problem. The problems you're solving now are, obviously scientific problems. As you get into industry, your problems become more grey box, more poorly defined, mixture of quantitative and qualitative, involve communication with people, organisations, risks, uncertainties. So it becomes more messy, more difficult, non-scientific even sometimes. And this is the real world. So this tool set is designed to go into that level of analysis. So I'll just set you a little problem here, given our dialogue, our conversation. There's such a thing called pestle analysis. You may or may not have heard about it in the academic world, and it stands for this: political, environmental, sociological, technological, legal, and environmental. So those, from experience, are the key factors to look at the context of your project. So the background of your project, what's affecting your project from outside. So this pestle analysis is basically a free-form narrative of what's happening in those areas. So remember, we talked a little bit about unmanned air vehicles. You perhaps have done the background reading. I've provided a source on unmanned air vehicles. But I just wanted you to think about, what do you think are the political factors? You know, from your opinion, it's your subjective judgment. What are the political factors if you were doing a UAV project? It's a very open question. I just wanted to see what sort of answers, based on what I've just said, you would come up with. I'm going to do this using Mentimeter, which is a new system at the university. So if I present this slide, you should be able to interact with the system like so. So you should be able to go to www.menti.com and put in the code, and it should be able to answer the question. We should get some sort of interaction. I know what unmanned air vehicle is a very open problem, but just to get you thinking about political factors. You're right. Yeah, I agree. Oh, hang on. It's the wrong question. Good start. If you answer the question on the screen, it'll be okay. Yeah, I'm sorry, I asked two questions there. Yeah, if you answer the one on the screen best you can, I guess there's a combination we can do. It's interesting. So what do you think? At least it gives you some, some insight into what you think as an engineering community, the political factors. Because governments have to be voted in. If you work with the UK government, then if you're a supplier to the UK government, you're under a lot of scrutiny from the voters, from the taxpayer. Why should these suppliers be supplying the UK government? Much more so than any private industry. There's particular public domain rules for working with government. And also, as you see, in a political environment, you lose politicians very quickly. So they can make decisions which will drive commercial projects into all sorts of different trajectories. The famous one is the Typhoon jet aircraft, which was originally a certain mode, I think it was. I always get this the wrong way around. It was an air-to-air aircraft, and then there's a political decision to change it from air-to-ground capability. So you can imagine the radical engineering changes you have to make to a project like that, making hundreds of aircraft at Wharton. The design decisions which had to be made were extraordinary based on political decisions. And as you rightly say, sustainability, previous disasters. I'm trying to avoid looking at Ronaldo. He's steps over the ball too many times, doesn't he? So interesting, yes. Thank you very much for that. Let's go back. And also, so you can see how it's a serious issue. Political, it could be the major cost driver in your project if you're working in an interface with the government, especially defence or sustainability in regulated industries. When I worked for National Grid, the people in Ofgem who were supposed to be the decision makers for gas distribution, there's only one person in Ofgem. Everyone had left at the beginning of our planning period. So everyone was new on the Ofgem panel. And that has tremendous impact on their decision making. They're not experienced. They're experienced elsewhere, but they're not experienced. So yeah, so project management is a research topic in terms of the amount of data. Artificial intelligence is a research topic for everyone, I know. I started off in '99 on artificial intelligence, so it's amazing how things turn full circle. Especially things like neural networks, so-called deep learning, where a neural network has many, many layers of nodes and connections. So it's able to have a high expressivity in terms of how it can express equations and relationships between data. There's just so many parameters, so many nodes, so many connections. It's very expressive. And these things. And the key part here is teams. People work on projects. So psychologists and sociologists have a real added value to teams. You know, the philosophy of working together is changing. And here's some of the historical research areas, things which have now passed into conventional knowledge. So things like here, earned value and project evaluation review technique, critical path method, systems theory. They're all common techniques which we learn as conventional techniques now, where there used to be research early on when projects were new. So it's interesting to see where the trajectory for research is going there. And this new thing here, agility, which is about having some sort of rapid cycle in the planning process. You only do what the customer wants, and then you release a version of the project every month or every week, and the customer says, okay, we've changed our mind again, we're going to, you know, so the planning period is iterative in agility. But it's not something we cover, it's more of an advanced technique. So there's lots of different techniques out there which are research related. I advise you, or recommend, sorry, I would recommend you to look at the APM website and look at the student membership there. It's a very accessible body of knowledge. They have special interest groups. They have all sorts going on, blogs, events, and these things for students. If you're interested in project management, it's probably the first go-to place. They're the UK Association of Project Management. There's the Project Management Institute, which is the American version. So the PMI is in the States. And these two things are I guess not competing against each other, but they're the recognised entities in UK industry. There's our friend Agility. So there's this Agile and DSDM organisation. Yeah, so this Agile was born in software development, and it's trying to spread out into other areas. And it's basically release a version of the software every so many weeks, and always have the customer or representatives of the customer telling you what they want in the room, in the team. So you're not making something which they don't want or don't understand, I think is a better word. So the requirements capture is more accurate. So it's basically a fundamental departure from project planning which has gone before. Okay, so all these things, this is our core structure. These are the main things we're going to be looking at during our period of time. And they are all fundamental areas of project management. So they all have a particular skill set or tool set to to work on. And we're going to have an industry speaker as well. Bring one of our colleagues in from industry to talk about project management. The assessment for the course, it's 50% multiple choice questions, which will be online, and it's 50% written exam, which is, I believe, January. It was last year. So January, and somewhere, I think after the EVN tutorial, or the quality, we'll be very specific about it next week, is the multiple choice questions. And you're tested on the first half of the course, MCQs, and then the remaining parts of the course is a written question. Is that okay? Is there any questions at the moment? We've got a few more problems to address as we go forth. So, in our teaching and learning theory, we kind of tell you what you're supposed to be able to do. So there are intended learning outcomes for this session. They tell you what you're supposed to do, and then we teach you how to do them well, and then we test you on how well you can do them. So it's a more tangible, practical way of structuring teaching and learning. So those things are the things that we want you to be able to understand or do in this lecture. Although this first lecture is not part of the MCQ, is not formally tested. So back to our Mentimeter. So how do engineers add value to a business through the delivery of projects? So how do you, as engineers, add value to business? That's our first ILO. I have something called the characteristics of projects. So I'll tell you about some common characteristics of projects on the next slide. But we'll go back to our Mentimeter. Let's see if I can I move this on? There we are. So it's our next question. So we've already discussed some of the things in the news, and they set the context for project management. So you should be able to link some of the formal methods and critically analyse where they're going right and where they're going wrong. So you should be able to form some sort of critical appreciation of the methods in project management. But it's very difficult to manage a complex project of many moving parts. It's very much a systems engineering type problem. Systems engineering includes a lot of quantitative scientific methods and also a lot of experience. So project management and systems engineering, cost engineering, they involve a lot of experience-driven work. Some of the employers, if you talk to the employers in BAE Systems, they say graduates are really great at algorithm-based work, but they still lack the experience of working in industry when they first arrive, which is clearly, a common thing. So if you give an open problem to an inexperienced graduate, they don't have the experience and soft and qualitative tool set to address that problem as well as somebody else. And that just comes with learning the environment. For example, working in the defence industry, you get to realise that some of the supply chain have all sorts of different CAD systems. And they've designed things over many years. And the suppliers, they move on, they're not particularly contracted to do things, they have lots of design knowledge, They have lots of different CAD systems which are difficult to get to communicate with each other. You know, you can have someone using Dassault, someone using an X, someone using AutoCAD. Sometimes they don't have a CAD system. And to solve the problem, you have to go back and remodel whatever you're considering in engineering. So the supplier relationship is actually the key driver in your engineering problem. The supply chain management is a lot more important than any engineering you could know. Anything you know about a CAD system, how to work it, how to get it to communicate, is irrelevant when you look at the supply chain management and the contractual issues. Why should suppliers keep up to date? What's in it for them? Are you paying them for it? Perhaps not. In a changing industry, then contracts are moving in between major suppliers like Lockheed Martin, BAE Systems, different places. So the supply chain is perhaps not as stable as you like. So definitely over budget. Exactly, some of these headlines. So thank you for that. The world is changing. Here's some of the things which I wrote down. Does it agree with what you wrote down? Maybe I'm a little bit more. I've seen a few more projects, talked to more people, been to more conferences, perhaps. Those are the things which are driving projects from the outside. If you're looking out into the outside world, it's volatile, it's uncertain, it's complex, it's ambiguous, and it's forcing decisions within companies. The classic is the supply chain. Did you know there's a place in America called, I think, Yellowstone Park, where there's a volcanic lake which, if it was to erupt, would cover the world in ash, and it would be the end. It could happen. If there was a serious eruption in that place in America, then it could have dramatic impact on the world going forward, as if we've not had enough trouble already. You can see technology, external forces of technology, artificial intelligence, and the collection of data, storage of data. In fact, Cambridge University said that artificial intelligence was the new asbestos, because people are making subjective decisions with algorithms which are driving your life. They're analysing data and putting you into tax brackets based on data they've collected from the country, based on their subjective judgment in the algorithm. So they're making decisions about parameter levels and how they're related and so on. So there are decisions being made about the algorithm form and what's important, what factors are going in there. So they're making decisions about what factors are important, collecting data, building a model, and changing your life. And you don't know anything about it. So that's the new asbestos. It's quite a bit sensational, but you get my point. And indeed, there's all these new business models. In the 1980s, 90s, if you're a manufacturer making a project, you tended to make something and forget it. But now, if you're in the commercial environment, like Rolls-Royce don't make engines and forget them anymore. They make engines and they lease them to people through power by the hour. So they don't make engines and sell them anymore, and then the customer says, oh dear, it's broke, can you fix it for us? Or have you got any spares? They now say, we haven't got the capability to maintain engines, it will cost us too much money, but you're good at it. So we'll lease the engine from you and pay you a certain rate, power by the hour. We'll pay you for the propulsion we use, and you maintain the engine, you upgrade the engine, you do what you like, because you're the engine expert. And that's called availability contracting. So there was a contract for the Lightning aircraft, which said, the MOD to BAE Systems, we want 80% of our fleet able to take off in the morning at 8 o'clock. It's your job, we pay you for that. So they don't own the aircraft, they lease and contract for availability of the aircraft. So there's all these new business models which have a different cost model behind them. It's a fundamental difference to make something and sell it than to make something and own it and lease it to someone. And it's supposedly more cost effective because if you're making design decisions, you own the problem because you own the engine, you're leasing it, so you can make a more optimal decision from a systems perspective. So, the world is changing, and here's some of the example projects we've been talking about. The Space Shuttle is an interesting one because in the assumption set for the cost model for the Space Shuttle, it was supposed to fly 52 times a year. So you could recover the cost across 52 missions every year, and there's a clear example of optimism bias from people who want a project to go ahead. So the people in NASA convinced the US government it would recover more cost. Well, it didn't happen because of the complexity of the technology and the problems involved, and all sorts of other things. So there's the Typhoon, the most integrated system, one of the most integrated systems, which means if something goes wrong in the project on one part, it impacts so many others. So the level of integration in projects is really an important factor. And I've put here a National Grid pressure reduction station. So I used to estimate the cost, the average unit cost, at the planning level, at the high planning level, for those sorts of things. Okay, so you can quickly see there some of the things which are problematic in those types of projects. I could maybe make a point about the Boeing and the Airbus, is that the same customer requirement for Boeing and Airbus led to two different solutions, radically different solutions for the understanding of the market. Boeing and Airbus felt that the future would involve transporting lots of people around the world to large global centres which would require large aircraft to transport lots of people at the same time, whereas Boeing felt differently. They felt they'd be more frequent flights to smaller airports, and sustainability being some sort of mediator. So the requirements interpretation in that particular project was a key thing. And you see recently for the Boeing Dreamliner, the race to get to market faster with new technology cost them a huge problem in safety. So they created a showstopper, a safety event which nearly destroyed the business with the crashing Boeing Dreamliner with a control system, which was in the news. So as you go through life and see these different projects, you become aware of the fundamental flaws and problems with projects. So I'm going to ask you a question about what could go wrong with a UAV, with a UAV system. And to help you along with that, I've just got a few things here to describe about UAVs. They tend to, in my understanding, consist of an actual vehicle or even a fleet of vehicles, depending on the application. And they tend to have maintenance bases or support bases and a control base as well. And indeed, you're going to need some sort of logistics and transport. So that's some of the basic things you might expect from a UAV system. And if you're on a project to deliver a UAV system, it could consist of those particular things. When I was at National Grid, at the completely other end of the spectrum, they were beginning to use drones as inspection vehicles for pipes. So if there was a gas distribution pipe across a canal or a river, fast-flowing river, or a very inaccessible railway location, then it would be more cost-effective to fly a drone down the pipe with cameras to inspect rather than using scaffolding and people. So drones and unmanned air vehicles are becoming more and more cost-effective solutions, which is why I picked it as a potential project. So why do projects go wrong? All these things I've been talking about, most things go wrong at the beginning. People make decisions at the beginning where there's little time, there's less experience, and they have the most impact. So the early decisions on requirements and design, perhaps when the project is ramping up, they have the most effect. So poor communication with your customer can cause real problems. If you can't communicate about the requirement, then that becomes the major problem with the project. I remember agility was something which we were trying to do to mitigate that in software. So those things are some of the reasons why projects go wrong. People think of extra things to do, so you've got to control people on the project from trying to do extra things which they think will be value adding for the customer. So you get this thing called scope creep. So what happens is, we'll just do an extra this, or if we add an extra component here, that'd be really good. Or perhaps we use a different material, or let's put surface finish on this particular mechanical engineering to improve the aesthetics. Suddenly you're doing a different project. So scope creep is a really, really important thing to think about. So there's lots of ways projects can go wrong. So you need to have some number of factors to say how they go right. And there's the classic ones of costs, performance, and schedule. So they're the famous kind of factors when people talk about projects. Is it on budget? Is it on time? And is it performing as you want it to do? You know, is a project going to do what the customer wants? So therefore you've got this other factor called the voice of the customer. And some people in industry would argue, if you're doing something which the customer has not told you that they want, then why are you doing it? Because it's not adding any value. It's waste. So the voice of the customer is really important concept. If you're doing things from your side, from the supply side, and you don't know whether the customer wants it, then it's a waste of time. You must engage with the voice of the customer. And there are other success factors like repeat business. If people are coming back to you, that is success. And it's not just on budget, on schedule, and the project performs. You know, it's able to fly at the right height for the right length of time. If it was a UAV, it's able to carry the right payload. It's easily usable. You don't need much training. It does its job, etc. You know, the performance of the project could be going well, but then it's wider stakeholder groups, and what are they thinking? So the suppliers, do they think it's a good project? Does a wider customer engagement group think it's a good project? Do the customers of National Grid see a drone flying down a pipe? Do they think that's a good thing? Is that a successful project to them? Is it sustainable? So there's a wider set of factors which says why a project is successful or not. Not just cost, performance, schedule, but also intangible, more soft and qualitative factors as well. I guess underpinned by the voice of the customer and underpinned by this more qualitative factor called benefits realization. So these are wider intangible factors which occur after the project has ended, benefits start to accrue. So National Grid could be seen as a high technology company. They could be seen as progressive. They're saving money on inspection. They're more effective. They're safer because they're able to get to equipment and pipes which were inaccessible before. There's all these benefits which are accruing after the project investment has ended, and that's the benefits realization. And benefits can be, you have to try and measure them using key performance indicators or something similar. So you have to try and put a metric to them. We can see how benefits are a wider set of the literal benefits. They're intangible, they're more, say, maybe political. They could be more, in terms of people might see National Grid as a great place to work. It's got higher technology. It attracts more people, more higher skill levels. It's a more interesting job. All sorts of different things are part of the benefit set. So have you been thinking about your particular UAV application? Maybe a drone. It could be a student project. You could be building a drone from a kit. Or you could be thinking of more commercial, high capability drones. So where could your project, given all this conversation, can you reflect on where your project could go wrong in particular? So let me go back. So if you reflect on your choice of UAV project, or the concept of an unmanned air vehicle or a drone, how could your project go wrong? You're to deliver a drone to an organisation for a particular purpose. If you think of specific ways, given our conversation, is that a fair question? I know it's quite open, and it will be specific to the way you're thinking about UAVs, but at least you give us some time to reflect on what could go wrong. Maybe it could be something technical, specifically technical or political. Murphy's Law, yes, exactly. Over budget. Corruption is a more common one than you think. I don't know. Second year undergraduates, what do you do? I don't know. Incorrect reference data. Interesting, the bankruptcy one. I was once in a project working with a company, and everyone got up and walked out all of a sudden. So our main supplier's just gone bankrupt. We're out of here. We've got to solve this problem. Everything stopped. So bankruptcy, yeah, I've seen that before. Policy changes. Team disagreement, yes, there's the way teams are operating with each other. You can get conflicts. Teams are at different stages of development. You could have a new team which is in conflict, is trying to learn how to work with each other, and they're making mistakes, or they're slow. Maybe they don't have the right skill set. They're still training. It's quite, yes, interesting. Funding as well, exactly. So sometimes projects get cancelled. There's a portfolio of projects. Projects are cancelled if they don't add value to the organisation, and another one is better. So there's some good points there. Optimism, freak weather, exactly. Yes, exactly. So thank you. Yeah, so there's some moot points there. Low specification, the battery life is a good one. I've seen that on Lockheed Martin equipment. vastly overspecified capability. They could have saved a lot of money when we did value engineering. So you can overspecify equipment on a project, it becomes a waste in terms of specification. Unavailable parts, yep. Sometimes things can go obsolete. You're making something, it's very common nowadays if you start to develop a design for something in aerospace, by the time you get to the end of the design, half of the design is obsolete. You can't get it anymore. There's also lots of counterfeit parts in aerospace. So there are parts of aircraft which are not the official regulated mechanical engineering. They're actually from false suppliers, and they're not to standard. They just look like they're to standard. So there's counterfeit parts in the aerospace supply chain which you have to be aware of. So there's some good points there. So I think you're beginning to get the point. There's all sorts of ways projects can fail. The space shuttle disaster we can talk about more in the risk lecture. And I put the interesting one, the Sinclair C5, which is there in the bottom right. Bottom right there. So that is actually in the show, well, it's in the foyer of a company called Hyde in Manchester, and they make the tooling for Airbus. So they make the tooling which keeps the main planes or the wings in place while they're assembled and manufactured. So they make the tooling for Airbus, and it's like they look like huge N-shaped pieces of metal which keep the aircraft wing in place. And they built the tooling for the manufacturing of the C5, which was an invention by Sir Clive Sinclair, the guy who invented economic home computers like the ZX Spectrum, ZX81. And it never sold anything because he got the customer requirement completely wrong. It was all from his perspective. He invented something he thought people would want, and he was wrong. So he got his market research wrong. And this company in Hyde had built everything and never sold a single unit. But they were paid by Sir Clive Sinclair from all the profits he made from his home computers. But it was a real disaster in terms of understanding the market. And you'll see later the space shuttle disaster can sometimes be attributed to old-fashioned organizational management of command and control, of an authoritative way of managing people from top down, do as we say, sort of culture, instead of a collaborative, bottom-up sort of culture. And so one of the reasons behind the space shuttle disaster was really the way the organisation managed itself in terms of this command and control culture. So it's a cultural thing which led to poor decision making. Perhaps, people felt under pressure from a command and control culture which led them to make perhaps an optimistic decision which was disastrous. One of these showstopper risks, when this risk happens, it's a complete disaster. Nimrod was one of these projects where there was too many suppliers fighting each other. So the supply chain was fragmented, and there's lots of communication frequency and breakdown in communication, different things like that. So, okay, so for the next, we're moving on to this little part of the introductory session. I can give you 5 minutes. Would you like a 5-minute break? I don't want you to leave the room because that will not be 5 minutes, but do you want a 5-minute break just to relax and talk to each other? So let's do that. So I'll come back to you at 10 past. Okay. Hello. So welcome back, everyone. It's now let's get back focused on the slides. So it's a good thing to think about some definitions and some explanations of what is meant by a project. So what would you think a project is? And I think there are several definitions from different organizations and academics. And here's a few definitions from academia and also the APM. And I think we take the first one from Turner: an endeavour in which human, financial and material resources are organised in a novel way to undertake a unique scope of work. So scope has a particular meaning in project management, which we will see. And I think the key thing here is the uniqueness. So it's like the APM says, it's a transient endeavour. So it's a unique, transient endeavour undertaken to achieve a desired outcome. So that's a quite succinct definition from the APM. And project management, the process by which projects are defined, planned, monitored, controlled and delivered so that agreed benefits are realised. So it's that notion, that concept of benefits realisation, which actually doesn't have to happen straight away. So those definitions should reflect some of the things we've been talking about in terms of there's a uniqueness, it's a one-off event, it's not business as usual. People have this saying, there's a saying called BAU, business as usual, which is an operational term. That means day in, day out operations for organisations. A project is a unique one-off thing which is different to business as usual and tends to try and make changes. So a project is a vehicle of change to a new state of business as usual. So companies use projects to change their business as usual to an improved state. So it's more cost effective, more capable, more competitive, more profitable, more technological. Lots of these benefits. Easier to use, more regulated, aligned with strategy. All these different things are the results of a project operating on business as usual to make a change. And you can see there are both quantitative and qualitative objectives as well. So you can see how the objective could be to achieve something at a particular cost during a particular time period. For example, So each project has a very typical life cycle, which is captured at a very basic level on this slide. And what tends to happen, if I was just to describe this, is that an organisation, which could be any organisation, is operating at business as usual, and then he wants to do projects. And why does he want to do projects? He wants to do projects to become more competitive, better at what it does. He wants to do projects to be in line with its strategy. So the organisation's strategy is where it's going, where it's going in the long term. If it was a ship, it would be picking its port. Where is it going? And the projects will be movements of the rudder to get it from A to B in terms of a strategic sense. So projects are aligned with strategy, and they're used to accomplish change, to give the organisation its strategic intent. And what happens is there are many different projects it could potentially do. And so there's some sort of decision-making process goes on at the senior levels of an organisation, where all the experienced people form a decision-making committee or a team, which sometimes you see occupy a space called the Project Management Office, or they are termed part of the governance of project management. So they're a team of very senior people: head of risk, head of cost, head of manufacturing, head of supply, head of procurement, lots of other senior people, sometimes termed greybeards in industry. They're really experienced people, and they're answerable to the board of directors. And indeed, there'll be directors on this decision-making organisation team as well. And they look at projects, they look at what's possible, and they select projects to do for the organisation based on a set of selection criteria. And they make that decision to make sure that the company becomes more competitive, how much risk it's about to take. Some organisations like to take risk, others don't. So sometimes you'll get lots of risky projects, or perhaps an organisation is risk averse and it does lots of safe projects. But there'll always be a very risky project as part of a development of a strategy anyway, because projects are risky, and so is being in business. So there's this organisation of people, this project management office, governance of a team of senior people. They get all sorts of project ideas given to them. They make a decision based on a selection criteria, and they do that when they're given an outline business case for each project. So each project concept has an outline business case. And what I mean by an outline business case is something which is high level, and it talks about things like the project objective, the budget, the timeline, the major risks, the return on investment for the company. So really high level stuff, no detail, really outline. So there's no detail behind the cost estimate, there's no detail behind the schedule, there's no detail behind the objective. It's a really top level outline business case. If the project is successful, then it goes forward to be defined. So we start then to talk about different concepts. So you get to concept design level, where given the outline business case, you can start to create different concepts which have perhaps, from an engineering perspective, let's say, you could have concepts which are different levels of mean time to repair, different levels of mean time between failure, different weights. If it was different concepts of an aircraft, they would weigh differently, they'll be more reliable, less reliable, they'll be more maintainable, less maintainable, they would carry more people or less people, they'll be more supported or less supported. So you'll get a lot of high-level concepts which are in line with the outline business case and the objectives of the project and the initial high-level requirements from the business to be in line with strategy. So then you do a bit of optioneering and you choose your concept, which is the most favourable, the most optimal concept. And people like Boeing and Airbus are doing this. They're considering all the different aircraft concepts. Are they going to introduce an electric aircraft? What is the carbon footprint? What's the range of the aircraft? How many people? How much is it going to cost? What's its materials? And this is all in line with the strategy of the organisation. The strategy might be, we're going to be the most green aircraft manufacturer. We're going to have the strongest supply chain management in case of problems with supply chain. So we're going to be the most resilient. So all these concepts and things are in line with strategy. So your outline business case is talking about these high-level things, and it leads to these different concepts at high level with different specifications, as I say, based on reliability, sustainability, maintainability, weight, life cycle cost, different levels of technology, complexity, uncertainty, and so on, manufacturability, all these different high-level things. You choose a concept, and then you go forward to detailed design. And that takes a lot of effort to detail things. But I say this, there's a lot of iteration going on, because you go forward a little bit and go back, maybe change the concept. But you move towards the detailed business case. So you've started off with an outline business case, in line with strategy. You go forward to a concept design. You pick your concept. You then go forward to a detailed design. A detailed design of a detailed planning of the project. It's a project we're talking about. Then you go forward to actual execution of the project. So you go forwards to actually running the project and getting some deliverables and monitoring progress against your detailed plan. And then once you've monitored and made changes and maybe modified forecasts and these things, so you've executed the plan, then you close the project down, you commission the project, you record your lessons learnt, and you go into a phase of benefits realisation, which is the extended project life cycle. So there's some really high concepts in a project life cycle. But fundamentally, you have these things happening. You have the definition phase. What's the project goal? What's its specification? Who's responsible? What are the tasks? Then you go forward to the planning stage, where you've got detailed schedule, budget, resources, risks, staffing. So that's a more detailed definition in the plan. Then you execute the project. You run the project and start to monitor through collecting data and reports, and then you close down the project with these different things. So for your UAV, can you think of a detailed project activity which you would see in your project? So given that I've just quickly outlined a project life cycle, what sort of activity would you be involved in on your project? If you were on your project, what would you do? Would you be a concept designer? Maybe a finite element analyst in the detailed design stage? Maybe a project manager monitoring, collecting data from the project as it progresses? Oops, got this right. Well, I didn't put a Mentimeter on this one. I thought it'd be better to have a conversation. Okay, so for the next, I'll give you 5 minutes. Just talk about project activities for a few minutes with your colleague and which parts of the project life cycle they're from for your UAV. So Just give you some space to think about things, maybe talk to your colleague, maybe do a bit of desktop research. Think about, okay, what sort of activities would be on a UAV, or the project you're reflecting on yourself, your project. So just give you a few minutes to do that. Okay, so we're back online. If it was from my perspective, I would be responsible for supplying cost information to the project manager. So my role, remember my activity was, my day job at National Grid was collecting information from finance on the ERP system, was talking to everyone involved let's say it was a valve project, talking to everyone involved in valves, from finance, operate and maintain, asset integrity, procurement, pressure management, all these different people, get them into a team, asking them what the cost drivers were, collecting the cost data from the ERP system, building an estimate using my expertise, and then validating our estimate with the team and giving that to the team leader who would then give it to the project manager. So that was my role in National Grid. That's what I did. That was my activity. So hopefully you've learned a lot from your colleagues. So we've discussed fundamentally what goes on in a project. Here's the BS standard 6709/2010, which gives a bit more insight into the different stages of a project life cycle. So there's a bit more detail there, but you're moving from high level to detail as you go forward through each phase of the life cycle. And each phase of the life cycle has a decision gate, a so-called freeze gate, where decisions are made about whether the project has reached, has completed enough progress to say, okay, we've gone through the concept phase and we've made all these decisions, now we're going forward to the next phase. So you have these freeze gates, which will be part of the organisation standard. There'll be a standard life cycle management template, and it'll all be understood and agreed by everyone in the organisation. That's how we do things. This is where we make our decisions. We're heading to freeze gate 1, then we're going forward. So you've got these decision gates and you've got these phases of a project life cycle. Here's the APM version, which is perhaps now a little bit more understandable. It gives you the basics, what you need to understand. You've got the concepts, the detailed definition, then you implement, you hand over to your customer, which you then operate, the customer operates, and then there's a termination and close out. So that's our project life cycle. And during that project life cycle, there's different levels of things going on. And the classic thing in project life cycle, from my perspective, say from a cost perspective, is that you don't spend much money at the beginning. You've just got people making decisions. So you don't spend much money, but the impact of your decisions means that you incur a lot of cost. You commit a lot of cost, So you might only incur a small amount of cost at the planning stage, but you're committing a huge amount of cost up front by your decisions. So if you're poorly prepared, if you don't have the right information, then you're making suboptimal decisions for the rest of the project, which are all baked in. They're all frozen into the project. You can't do much about it. So you've got to do things right at the beginning. You can also see that stakeholder interest also fluctuates. Stakeholders can get very interested at all sorts of different stages. The client interest is very strong at the beginning, and that's something you have to manage. If the client loses interest, then your project can be suboptimal as well. So you can see here how the client interest is really, everyone's really enthusiastic about what the project's going to do, and then they disappear. And they come back at the end, and maybe you need them a bit more in the middle ground to help you with the project. And another thing, you've got a very high level of uncertainty at the beginning. Now you don't know much, so you lack knowledge, you lack data, time to understand things. So there's a lot of uncertainty at the beginning of the project life cycle. So that's a really interesting slide there. That kind of gives you a basic view of how things are changing during our full life cycle of the project. And this is just to echo really what I just said. It was originally based on a Rolls-Royce project many years ago, but it's rung true. No one's ever disagreed with it. In that, you only spend a small amount of money on designers, but they commit all the cost in the project. So there's there's got to be lots of collaboration and communication at the beginning to make the best decisions. So your best way of working is to engage with each other. You know, you'll be future colleagues in industry, and your best way of working is to talk to the person next to you, around you, to make the best decisions. So you must communicate, learn how to communicate, and tear your hair out as well at the same time, when you can't see things going your way. People don't necessarily share the same view of yours on a project, so you have to communicate and learn how to put your case forward in different environments. Indeed, if we're talking about the full life cycle of something, lots of cost in a project is during the use phase. If we're looking at the full life cycle cost, and it's usually represented by this iceberg. So the manufacturing cost is so much, but then when it goes into service, and it's operated and maintained, the project is actually in use, then about 80% of the costs of the entire project are represented in the use phase of the project. And that wasn't recognised until perhaps late 80s, seriously. Which is why we've got all this availability contracting and power by the hour by Rolls-Royce, because they're levering this iceberg. They're using this iceberg as a business, as the edge in business, as their competitive edge. They've looked at the iceberg and think, we're going to use this to compete and conquer the world, as it were, in terms of propulsion. And it's interesting as well, during the pandemic, they had to lay off so many people at Rolls-Royce because their business model was based on use. So suddenly no one was using Rolls-Royce engines. Everyone was in lockdown. So they lost loads of money. They only made money when people flew the aircraft because of their power by the hour business model. So because of their innovative business model based on the iceberg, they had to lay off lots of the company because they weren't making money. If no one flies, they don't make money. Okay, so this is really another example of the project life cycle used in defence, back to our Queen Elizabeth aircraft carrier. And this is the formal so-called CADMID cycle, which is a government, UK government project life cycle concept. And that's how that is organised. So the CADMID cycle is well known, very well known in defence. And indeed, we've talked about technical systems so far, but really we're in socio-technical systems. We're working with people. And back to the idea, or back to the demonstration of research subjects I showed you earlier, the impact of people on progressing projects is becoming a really important topic. And if you look at those points on the screen, are you thinking about that while you work with people? So are you thinking about these things? Are you asking those questions? People learn differently. This is a really important thing for me. I have to understand how people learn differently and try and engage in different ways. So the learning community is a balanced response to everyone. So that's one of my concerns, actually, is how people's individual learning styles and development cycles. So doing a project, when you start to ask these sorts of questions about people, you begin to realise the sheer volatility and variation in projects and working together, and why it's really important to have a profession which manages it and deals with it in a scientific way. So, okay, we've looked at different parts of planning in our core structure. So, what are we're going to pick on the definition stage of a project. It's So remember, there was a concept and then define. So the define stage of the project. And this is what we do during project definition. These are the steps we take. And this is from Larson and Gray, you know, the textbook, which is one of our textbooks for the course. So we've got these 5 main stages. So let's go to those stages. I've put some extra slides in here, which I think I've already covered requirements. That's okay. So in terms of looking at project scope, this is our checklist for defining project scope. And what is project scope? So this is our definition from our other textbook, Pinto. He's very well known in project management. He's good, another good academic, as well as Larson and Gray. So you can read that. It's everything about a project, the project scope, work content, as well as expected outcomes. Consists of naming all activities to be performed. So we're going to have to define all the activities as parts of work packages, the resources consumed in a work package, and the end products that result, so the deliverables, the products. So you've got products being made by work packages, which are activities. And to complete those activities, to complete those products, they must be done to particular quality standards. And everyone's perhaps heard of ISO 91000 or ISO 90000, the quality standard. So they must be done to a certain standard of quality, which is defined as part of project management. So the project scope includes a project's goal, constraints and limitations. So there's a lot of things in there which we're going to be dealing with in our second lecture. So we've got deliverables, activities, resources being consumed in the activities, all done to a quality standard. And remember that we started off the project with a goal, an objective, and we're constrained by budget. We've got limited capacity, we've got limited resources, we're limited in time, we have limitations. So it's starting to make sense. Project scope is starting to make sense. And here's an example scope statement with some example content. So things are beginning to get a bit more tangible. That's an example objective for a project. An example scope description with some specific things, products, deliverables, and you've got some milestones in there. So important times in the project where you know, which are important. Maybe you've completed a major product, or you'll have to make a major decision. You have a milestone there, and you have perhaps different technical requirements you have to fulfill as part of the project. It could be regulated, could be some legal requirement. And then you've got limits and exclusions. So what are you not doing? That's what you are doing, but what are you not doing? So very basically an objective, a scope description, things we're making, products, milestones, some technical requirements, and some limits and exclusions. So for the next few minutes, can you think of your own project objective and deliverables to go into your scope statement? Just for a few minutes. Let's give you a few minutes to 1:45, a bit afterwards. just to reflect on what the objective for your project is. If I just put this back on the screen.
Slightly confused with the project scope, description, and the deliverability. So basically, is it, project scope is less detailed, whereas the deliverability is in more detail? I'm slightly confused with the difference.
What happens is you get, if you're at the concept stage, if you're at the early stages of a project, then things are quite high level. So you'll see that some of this things about scope and scope statements are pitched at a high level, and then as you go to the detailed planning stage, you start to fill in the details of the activities and the resources. So some of your, depending on what stage of the project life cycle you're at, then the project scope is either defined at a high level or a detailed level.
Well, the detailed level should be deliverability, isn't it?
Yes, you can.
From the example that you gave us, that's where I see the difference.
So those sorts of the decisions on your deliverables, perhaps they can be quite conceptual at the beginning, and you could have different options A, B, C, and D at concept stage, and you decide to go forward on a particular option. Then that option will consist of a particular configuration or perhaps natural number of deliverables. But at some point you get to the conceptual, the phase gate, make a decision, and then go forward to detailed planning. So some of these deliverables have not been defined at all in detail. So you could say something like a fuselage or a main plane, but you've got no real detail of that. You don't know what materials. Perhaps you've not committed to a span on these different things, because the functionality is more important than the actual embodiment. So at the beginning, you make decisions about what your project's going to do. That's the functional bit, and then the functional bit is then linked to actual products and deliverables. So you have to make your conceptual decision about what we're going to do. So you have an initial project concept, which is a requirement. Then you link the requirement to function. So what is the project going to do? Then you link the project, what it's going to do, to actually what it is, what it looks like products. And then once you've kind of decided on a high-level product, then you can go forward and detail what that's going to look like and how you're going to deliver it.
That's going to be the deliverable bit. More like you just basically expand everything.
It's basically possible to talk about every aspect of a project from a high level. You can talk about the cost, you can talk about the requirement, talk about the concept, talk about the function, what the project's going to do. You're going to talk about the benefits of the project. You can talk about all of that at a concept level, a very high level. So you can then you can even talk about its basic configuration. It's going to look a bit like this. Then when you move forward through the project life cycle, then you detail that. So you come more towards detailing a plan which will deliver that. So you move to a more detailed planning stage, and perhaps in the implementation of that plan, then you come up with even more detail. So the general passage, your general journey, is moving from minimal project definition to detailed. So this current scope statement is quite high level, but it is saying what the deliverables are going to be. So decisions have been made about the fundamental deliverables of the project. I mean, sometimes organisations don't know what they want, and they have to employ consultants on their behalf to work out what they want. It's like the nuclear industry. The UK government will employ a consultant in the nuclear industry to tell them what do we want from a nuclear reactor. So I think the answer to your question is it depends on the stage in your project life cycle, how much you can say, and what decisions you've made about the detail in your scope. Does that make sense? Very good question. It's a moot point, basically. it's the important point. Okay, so we're back. So just to review that, we're talking about project definition. So remember we had a project life cycle right at the beginning. And we had a define stage here at the beginning of the project life cycle with goals, specifications, tasks, responsibilities. So that was our define project life cycle, and what we did was identify the main stages of project definition. And we were defining project scope, and we had a project scope checklist in defining project scope at the define stage. We had an example here. So once we've defined things, we can move on to more detailed planning at the definition stage. So, we're nearly done. It's important that we talk about the iron triangle. So this is, I believe, something developed at the University of Manchester early on in project management, and it recognises as a trade-off space in your project between cost, quality, and schedule. So that's quite intuitive, because if you spend more money, then perhaps the quality will increase. But then perhaps the schedule will increase as well. So they're all linked together in some way. And in the middle is scope. So you could reduce the scope, you could reduce what you intend to do. And if you did that, perhaps the triangle would get smaller, and there would be less cost. You would do things quicker. Perhaps the quality remains constant. Sometimes you could be behind schedule on your project, and you have to suddenly invest a lot of money to get back on schedule as part of project execution. So if you're monitoring your project execution phase and you're behind schedule, then you might say, okay, we're going to have to reduce the scope, or let's get some more resources here and let's spend a lot of money all of a sudden to get us back on track. Let's invest lots of money to get the schedule back on track, because we have to be first to market with this project. And perhaps we might make some quality sacrifices or have less quality. Sometimes if you allow the project to go on longer, you end up incurring more cost because the resources are there for longer. That can happen, but perhaps the quality increases as well. So there's a classic trade-off space there. Those are the key parameters in making decisions about your project in terms of keeping it on track. They're the key parameters. Sometimes the quality is performance, is substituted with the word performance or quality. So how could you modify your project in terms of changing cost, schedule or quality? Would you invest more in your project? What would that entail? Would there be more resources? Could you reduce the scope? Could you maybe pare the project back, do less? Is that in line with the customer's requirements? Could you go back to the customer? Or would you keep that constant? Would you increase the specification of your project output, of the actual deliverables themselves? Could you maybe reduce the specification of your deliverables, have them less capable, and therefore save cost and get to market quicker? So how could you modify your project in terms of these three key parameters, and what are the impact? If you change one, what are the impacts on the other two? And you'll begin to notice there's always some sort of knock-on effect between cost, schedule or quality. But it's where your main decisions will be made in terms of keeping your project in line or on track or on schedule. I did work on a data logger for a company where everything was over-specified, because in the project they'd had technical people all working together to get these customer requirements addressed, and they did everything without any cost information. So they over-specified everything because they wanted high performance, and because of the absence of cost information, they'd over-specified. The project was too high quality. And then they decided to do something about it and say, well, what can we do? Can we change our project so it's less costly? So yes, of course, it's possible you could change the specification of everything, lower it down. You can change the actual manufacturing methods to make them simpler, use cheaper materials. There's also all sorts of things they could do to change their project and make it less costly while keeping in line with the customer requirement. Okay, so we'll see. This is for the next lecture. So if we've decided our objective, if we've decided our deliverables, then we can move on to work breakdown structure. So this is just an inkling of what we're going to do next. We're going to write down deliverables, and then we're going to write down the work packages which make those deliverables. They're called the work breakdown structure. But that's for the next lecture. So finally, and I guess we've done this lecture a little bit backwards, is that projects are only viable when they're in line with strategy. So I've seen companies look at a project progress, and the project has got to its detailed planning stage. So it's gone through its outline business case, it's gone through its concept, it's got its scope statement, there's a detailed plan, and they've started to execute the project, and they've not spent the money on schedule, and suddenly the project is cancelled, because the project management office know that if they're not spending the money on time, they're behind schedule. They're not saving money, they're not spending it on time. So they just cancel the project because they know it's going to fail. So projects can be cancelled if they're no longer value for money. So we've talked about projects and being aligned with a strategy, but here's the bigger picture. You can have collections of projects working together, and they form programs. So projects interlinked using outputs from another project and forming inputs to other projects, for example, can be called programs. So you could have a program to create new manufacturing capability. You could have a program, to suddenly create new manufacturing capability in Europe for a new aircraft. That would be a program, a collection of projects. And the host organization, which has a strategy, is running a portfolio, and its portfolio is live at all times, and it consists of projects, programs, individual projects, and so on. So the organization which has decided its strategy is running a portfolio of live projects which are being cancelled, created, managed at all times. And these things are in line with risk and reward, say. Is the organization taking lots of risks? Has it got a high risk appetite? Is it looking to be highly profitable? Is it trying to create lots of profit all of a sudden because it's got a cash flow problem, which might be the case during the pandemic, post-pandemic? So the way the organization manages its programs and projects in line with strategy is portfolio management. And that's where our greybeards come in. So the whole point is to be aligned with strategy. And what happens is, once a strategy is developed by the organization, then it can create its project selection criteria. I mean, some organizations compete on cost. They want to be the lowest cost. Some compete on the highest technology. Maybe they're googly or something like that. Some organizations compete on quality. Some people would argue that nowadays an organization has to compete on everything. It can't differentiate itself like that anymore. Some organizations have very strong goodwill. So they've got a great reputation, and the goodwill, their reputation creates value. They can sell things based on their reputation and logo. So as my final question, in terms of your project, could you rate your project for each of these project selection criteria? So what's happened is all the greybeards, all the heads of the company, all the senior managers who drive all the cars, and everyone knows of the senior people, they've all come up with this selection criteria to enable them to make decisions about which project's going to go forward or not. So that the business, the company strategy, which has been developed at senior levels and by business unit managers and lower levels as well, importantly emergent development through lower levels, really important that. Then they've come up with this selection criteria. So your project, which you're kind of beginning to develop, perhaps along the lines of a project life cycle, where would you say it is with these particular set of criteria? What do you think? Could you score your project in these areas? Does anyone know what consistency means?
Can you do it again and again and again to a good standard of quality every single time?
Do you mean, is there a
consistent standard of quality?
That would be a good answer, but because I've not told you about this, This is quite esoteric knowledge. I wouldn't expect you to know it. It means it's consistent with the portfolio. So you need to balance your projects. Imagine if all your projects you did were risky. You would have a major footprint of risk. You'd have a major exposure of risk. So you need some sort of consistency so the portfolio is balanced. So you need some projects which will give you money, some which will take risk. You need some which are building capability. You need some which are improving your current operations. You need some which maybe develop new directions for your strategy going forward. So you need your projects as a whole, the whole thing to be consistent with where you're going in the long term. So you can't have an unbalanced portfolio. So a word for that is being consistent with the portfolio. Sometimes the very basic level is risk versus reward. A post-recession, companies are asking themselves, how much risk are we going to take? There'll be some people out there betting on taking a lot of risk and get a lot of reward, but if it doesn't work, they will be severely punished in the recession, I guess. It was a really important thing post the last recession. Companies are asking themselves, when do we launch our new product? Because we have to invest in a new product, it's going to take all our cash, but no one's got any money, so why should we build a new project? No one's going to pay for it. We're going to get no profit. So all these decisions are being made by UK PLC at the moment in the context of more major hits in terms of risk events. Okay, perhaps you'll let me know what level your projects are at later, or talk to your colleague about them outside of the lecture. Be interesting to see where your projects are in terms of profitability, consistency with the portfolio, aligned with strategy. Is it a risky project? Is it highly innovative, or is it a safe project? Does it use conventional technology in a pandemic? Does it use a lot of resources? Do you get bang for your buck? Those sorts of things. So those are the kind of range of things which are important to the greybeards in the project management office. And you do get these things called sacred cows, where a senior person is intent on a project being delivered which is close to their heart, but doesn't necessarily make logical sense. That's maybe the entrepreneur in the company. Okay, thank you very much for your attention. Please look out for next week's slides, or the next few days. It's good to see you. Oh, that was interesting.
I'll put them on the discussion board. Certainly put it on the, sometimes it's coming south, it's a one-off. deliverables are specifications, detailed design, manufacturing, they could be your deliverables, and then you could have work packages to deliver. So your detailed design could be a deliverable in the project, or it could be that your detailed design is part of the project plan if it's a product life cycle. I recognise that as being confusing. So project management is about applying the effort to the project. If the project involves decisions about concept design, detailed design for the project, they could be deliverables. And your design, your detailed plan of the project is about those deliverables and what you're going to do to make those deliverables. So that's the project. Whereas if your project is say a one-off aircraft or something like that, you could be making a bespoke aircraft for a commercial customer, then perhaps designing that aircraft is a detailed design of your project. But that's treating that as a project. The project is a product development cycle. So no, so the detailed design is a deliverable of the project. But the actual output of the project has to be detailed design. I hope that's okay. We can talk about that again, I think.
Okay.
I would just want to ask about like thinking I'm kind of interested in that. So do you have any like more resources that you can into?
I guess it depends which part of project management, because artificial intelligence has been applied across the board.
Do you have any
Yeah. Can I put? I'll put them on the discussion board. I think. Yeah, I remember that. Yeah, exactly. So I've used them in estimating, you see, in prediction, time and cost. So neural networks, fuzzy logic, these things.
All right. So I can find them like on Blackboard.
I'll post a few examples for sure. What's your name, sorry?
Giuseppe.
Okay. All right, thank you.
Hi, I just want to ask 2 questions.
All right, okay, sorry, yeah, come on.
Firstly, are lectures recorded?
Yes, I understand they are.
And also, this lecture itself isn't being assessed, the later ones are, right?
Yeah, so this is an introductory lecture, so I'm not going to test you on these things, but you need to know these things going into the...
Next lecture.
Yeah, so if I'd have not told you this, the next lecture would have been...
The company did.
Yeah.
So,
Or you wouldn't have understood why you were doing these things, or where things were, different parts of the life cycle.
okay, so the lecture is being thankfully recorded.
Yes.
That's great. Thank you very much, Mr.
All right, Bagley.
Dr. Becker.
Yeah. All right.
Hi, I didn't quite understand about the triangle. How are we supposed to apply and interpret the triangle? Like, if we change the color to
Yeah.
how do you affect, and then would it affect, I don't know, theoretically, what is the shape of the triangle, and like, how do we modify it? Like, what are we trying to do?
So, you might see in operations research, people do optimization. So they try to get a specific number, which is the optimal time or cost. Or say the number of hours of machine A versus machine B to produce something. You do get things like linear programming, simplex method, sometimes genetic algorithms. If it's more an involved problem. But people talk about optimizing things, and in doing that they have. If you look at optimization theory, you tend to have an objective function telling you, this kind of gives you a number, an objective number, and then you have constraints. So you could have cost plus lead time plus something else, and that gives you the number you're trying to optimize. Given the cost is between 10 and 1,000, schedule is between 1 week and 3 months, and the quality is between this parameter, the next parameter, let's say, we call it operationalising a concept. If you talk about quality as a concept, like surface finish is an aesthetics quality, then you operationalise that, give it some numbers. Say, okay, so the tolerances have got to be between certain micrometers of surface finish or roughness on the particular mechanical engineering. So it's possible to do optimisation using an objective function of some constraints, and it's algorithm driven, and it's a specific method. You would do a course on it, it would take, I don't know, operations research a whole semester or something like that, to learn all that. But if you come out of that, if you look at it from a qualitative perspective, you've actually got a trade-off space. So you're not trying to work things out precisely, you just know that if you change the quality, it's going to impact cost and schedule. It's like your informal objective function. It's a capturing of the main things in the project which are related, which you're trying to reach an optimum. And you think, well, I'm miles behind schedule. Oh no, I've got to spend more. What's going to happen to the quality? If you spend more on schedule, the quality might decrease. So it's a trade-off space. It means that they're connected somehow. So you can't ignore quality if you're spending more money, because that money should have gone on quality. You could have a limited budget. You've got constraints. So it's really a qualitative trade-off between the three important parameters of a project in terms of optimization.
It's a give and take situation.
Yes, but you need to include all of them in the objective function. The objective function is a jargon. It just means, taken together, we want this to be the optimal. So it's a qualitative optimization.
Not so much on the quantity side. If we were to change the quality, for example, the surface finish, the roughness, the micrometers, changing it into something like in numbers, and then we program it or like have it visualized, do people do that as well?
I guess it's a heuristic, it's a rule of thumb. There is ways of optimizing in project management. You'll see in the next lecture there's something called critical chain, which is looking at throughput. But it's very difficult to optimize such a complex thing. I mean, sometimes people use simulation. So they use Monte Carlo simulation, and they do what if and sensitivity analysis. So they try to, and sometimes design of experiments. So they try to, because things are uncertain and complex, it's very difficult to write down a deterministic equation.
So mainly the triangle is just for quality.
It's one of these experience-driven things. Practitioners have worked out that these are the three most important things, and that when you change one, it has a knock-on effect on the others. If you're keeping the same project, so you have to, you're moving around in that space to make decisions about keeping the project on track or changing the project in some way. Which is why you've got scope in the middle, because if you reduce the scope, you spend less money. The triangle gets smaller. Or you can end up spending more money on quality. But at least all those parameters are involved in trade-offs.
I always thought that the triangle had normally something to do with strategy, actually, of the company also, if you think about it. The strategy, like the way they're going to take, because like the triangle is just essentially there for you to visualize what are you going to be. Are you going to be focusing more on quality, the cost, or the time it's going to take? So then it's just correlate. It's just for you to have a visual representation of what you're doing, really.
Yeah, exactly.
That's essentially it.
Yeah.
Nothing much to it.
I agree with your point.
Except for that, yeah.
I think that's an excellent point. Yeah, take that on board.
Yeah. Yeah. Speaking of, sorry, go ahead.
No, I'm done with my question.
Awesome.
Yeah, thank you.
All right.
Oh, yeah, nice. Doctor, actually, I had a question about strategy, right?
Yeah.
Because Anik and I, we read a bit more into the case studies, right, that you posted for us, and for the UV, for example, right? And I always thought it was a bit interesting, the idea of like strategy and how it's defined, because I always thought like in the world now, because like of like different offers, you know, like how the world is also changing. I always thought that like because the idea of strategy is like if a project doesn't follow the strategy or sort of like the mindset of the company which is being contracted to do so, they probably normally like, would reject that project because it wouldn't make sense. It would be just a waste of material, waste of time, waste of resources, right?
It depends as well, yeah.
So that's...
I mean, sometimes you have to do a project for another one to start. You have to take one step forward. It's a bit like this lecture.
Sort of like that, yeah.
It's kind of like, you have to do this one to do the second one. I recognise strategy is a very complex area for sure.
Because, like, for example, like, at least for example, if I were to need, like, for example, a flap for the new airplane, for the commercial airplane that I would be designing or something, and I would normally seek out probably a company or something that is, at the same time, has a good strategy for, of course, tackling this problem. Also have, like, sort of like be able to, like, adapt and be, like, flexible enough. If, like, for example, if I would have to, like, redesign the shape of the wing or something, the attack angle or something. So, like, you're also searching for that in companies when you ask them to do like a project or something. And it's just I was just, as I was reading, I was just thinking about that. I was like, but you still need to be a bit flexible as well. You can't just like follow like exactly like word by word. What is your the company's modem sort of like?
I think you get into the world of product design.
I see.
I mean, we're looking at project life cycles, and sometimes they do coincide. But with something like that, you want a good relationship with your supplier.
Of course.
So you want the supplier as part of your design team. You want to be working closely with them and managing obsolescence as well. But what sometimes they do is they put like an envelope. This is where this is going to be, and they work within those constraints. But certainly the high-level parameters, so that because you've got systems, so the aileron or the flap and these different things are all part of the wing system, which is part of the aircraft system. So you've got subsystems, so it's a systems engineering problem. You've got a supply chain management communication thing you've got to do. They've got to be on board with the team. But at the same time, they're trying to make profit as well.
And
the best way to manage the risk of that is to have the most optimal contract with the supplier. So if you invest in your suppliers, they will provide that sort of expertise. I think it's interesting. It's kind of a moving part of the wing, isn't it? The flap. So
yes.
So there's a design for assembly issues. You could have. It's where you get everyone has to work together. You see, because the CFD will be going, I want this. You say, well, hang on a minute. We've got to assemble that and manufacture it. It's going to be really difficult. Because some of the geometries are too tight or
tolerances and everything. That you're going to be like critical factors there. I see.
Too many moving parts. Something like that. And it's got to be tested.
Of course.
It's got to be in line with the requirements management. So you've got to test the requirement. It's got the right materials. It's going to impact weight. It's going to impact maintenance. Is it accessible? Is it impact with the propulsion system? So I guess the whole thing is a systems engineering problem with a very large project team working together.
I see.
And sometimes you can have suppliers who won't give you certain information. They'll say, our part of this, our subsystem is this reliable, it has this weight and this cost. That's how we're telling you, it's our design, it's our intellectual property.
Of course.
So it depends on the contract. As much as I know, and as much as I've been involved in these different things, I mean, I've sometimes been to a company and say an old aircraft, something's gone obsolete and it's broke. It's no longer made by anyone, and suddenly they have to redesign, like an old aircraft, redesign and get a part which does the same function. And because it's critical that they do it, sometimes the supplier can charge as much as they want to replace that bit of the aircraft.
I see.
But I think it's all about the people working together in teams and getting the critical mass of expertise, and perhaps thinking about the definition. I mean, there could be one of your deliverables could be the concept design, and the concept design could have the configuration, and it could have that bit of the wing, which then in the detailed design, it could be another deliverable, could be that designed by a certain supplier.
Of course, yeah.
And that has to coincide, and that has to be managed configuration design.
Yeah.
So I'm not sure whether you get the actual CAD file to go into the entire assembly file for the aircraft. Yeah. But from a project management point of view, you'll have a concept design deliverable, a detailed design deliverable, then you get a manufacturing deliverable. So we've got a detailed, our definition of the project plan is detailed, but the deliverables are at concept stage, detailed design stage, these sort of things.
Different ones, yeah. I see. Thank you so much. And next session is going to be next week then, right? On Monday again.
Yeah.
That's it. Thank you so much.
All right.
Thanks so much.
Thanks, mate. AI.